Good morning class. Today I welcome you for the new point, that is Bragg's law. Okay. So we are going to discuss the Bragg's law, which is a part of a solid state. Bragg's law. Bragg's law was given by H.W. Bragg. Then this law helps to study the distance present between the layers in the crystal lattice structure. So this law helps us to find out the distance which is present between the layers in the crystal lattice structure. Now, atoms shows a definite regular repeating structure which is called as a crystal, which is called as a crystal, right? So now consider this is one layer, this is the another layer, and this is the another layer. Now here AB is an incident X-ray of wavelength lambda with the angle of incidence theta. It is reflected as BC. Then DE is another X-ray which is incident on the plane Z, and it is reflected as EF. Now the distance which is present between these two layers is D. Suppose BQ and BP are the perpendiculars which are drawn to ED and EF respectively. Now here the angle of incidence and angle of reflection are same. Same things goes over here also, right? So now in this case, the path difference between these two waves. So path difference present between the two waves. Which are those present between the two waves A, B, C and D, E, F is actually equal to what? PE plus QE. But if you consider the triangle, now in triangle PBE, so sin theta is equal to what? PE upon BE. Now in triangle QBE, again you can say sin theta is equal to what? It will be what? It will be EQ. Sorry, Q, or you can say even QE upon BE, right? So it will be QE upon BE. Now, therefore the path difference will be d sin theta plus d sin theta. How? Because path difference is equal to PE plus QE. Now what is PE? PE is equal to d sin theta. QE is also equal to d sin theta. So that is equal to twice of d sin theta. That will be equal to twice of d sin theta. Again, so the path difference, you can say that. So path difference is the 2d sin theta is equal to to the integral multiple. Integral is integral multiple of n lambda, is integral multiple of n lambda. So from this you can say that the two waves shows constructive interference. Therefore the intensity of the reflected beam is maximum. That is n lambda is equal to 2d sin theta. Here lambda represents the wavelength, d stands for the distance, and n is equal to 1, 2, 3 and so on, etc. So this is your Bragg's law. So याला जर नीट समजून घ्यायचं असेल तर पुन्हा सांगते मी एकदा. ब्रॅग्स लॉचा अर्थ नेमका काय आहे. ब्रॅग्स लॉ हा HW ब्रॅग्स यांनी दिला. ह्या लॉचा उपयोग कशासाठी करायचा आहे, जे काही क्रिस्टल लॅटिस स्ट्रक्चर आहे त्याच्यामध्ये जे काही लेयर्स असतात त्यांच्यामधलं जे अंतर आहे म्हणजे जे डिस्टन्स आहे ते फाइंड आउट करण्यासाठी हा ब्रॅग्स लॉ वापरला गेलेला आहे. राईट. सो नाव इथं बघा आता AB आणि DE हे दोन्हीही इन्सिडेंट रेज आहेत. इन्सिडेंट कोणत्या, एक्स रेज, ज्यांची वेवलेंथ ही लॅम्डा असते. नाव these are actually reflected as what BC and EF respectively. Okay. So now the distance which is present between these two layers, हे दोघांमधलं जे अंतर आहे ते आहे BE. बरोबर. B या पॉइंटवर Q, BQ आणि BP असे दोन परपेंडिक्युलर्स आपण DE and EF या पॉइंटला टाकलेले, या रेजवर टाकले. ठीक आहे. सो नाव व्हॉट हॅपन्स, मग आपल्याला असं कळतं की ह्यांचा जो पाथ डिफरन्स आहे तो काय आहे. सो द पाथ डिफरन्स बिटवीन द टू वेव्स इज ॲक्च्युली सम ऑफ व्हॉट PE प्लस QE. ओके. सो ते सॉल्व करण्यासाठी मग आपण ट्रायंगल्स कन्सिडर केलेले. पहिला ट्रायंगल जो आपण कन्सिडर केला होता तो होता ट्रायंगल TBE. So in triangle TBE we get that sin theta is equal to what it will be, simply it will be PE upon BE. Right. Another it will be what, again in triangle what QBE, you can say that in triangle QBE again sin theta is equal to QE upon BE. Right. मग पार्ट डिफरन्स इज इक्वल टू P. यांच्या जर किमती पण टाकल्या तर काय d sin theta plus d sin theta is equal to 2d sin theta. Part difference is actually 2d sin theta is the integral multiple of what, n lambda. का बरं, कारण हे दोन्ही जे रेज आहे ते कन्स्ट्रक्टिव्ह इंटरफरन्स दाखवतात. Therefore they shows an intensity of reflected beam is always maximum. So you can finally conclude that n lambda is equal to 2d sin theta, where n is equal to 1, 2, 3 and so on. So this is your Bragg's law. Okay, we'll stop here then.